Welcome to tutorial section 1-5, string variables. We've already worked in string variables, but today what we're going to do is we're going to measure a string variable. Remember, a string variable is any number or letter combination that will not be used in a math equation. Sometimes, though, we need to know the length of a string in order to plug that length into another program. So we need to learn first how to measure that length. So let's look at this program I've already put on the screen. Given a string, this program prints the length of the string. Then it asks the user, what is the string? The input will be $. It will capture the user's input. Let L equal len $. Print $, has length L. So I'm going to run this program as if I were the user. Watch closely what's going to happen in the output, and then I'll go over each line individually with you. So I press F5 to run the program. What is the string? So if I want to use the word Colorado as the string, when I hit enter, it's going to tell me that Colorado has a string length of 8. And if you count 1, 2, 3, 4, 5, 6, 7, 8, Colorado has a length of 8. Notice it told me what the program was going to do. That's what these first two print lines are for. Then it asked me what it was I wanted it to measure. It then took that input, that user input, and put it in the S string. Then we told it let L, meaning we want L to equal or be assigned the length of whatever the S string is. And len is the assignment word for, len is the keyword that measures length to the assignment of L. So it's measuring whatever the user's input was here at $, it's measuring that and then putting it into this container L. Then on this line, we're telling it, take whatever the user that we put in the container $, print that, also print has length, and then print whatever the measurement was in container L. This program will also measure spaces as part of that count. For example, if I were to run this program, and my string was, I love computers, it's going to tell me that it's 16. And if we go up and count, I is 1, space is 2, LOVE, that's now at 6, the space makes 7, COMPUTERS, that's 16 in all. What if I ran this program and the person put in punctuation in their answer? For example, I love computers, exclamation point. Well, we know that I love computers is 16, so we can assume that if the program is written correctly and punctuation is included in the count, that the exclamation point will make it now 17. 17. So it does count spaces, exclamation points, and other symbols. Anything that can be in a string will be counted. Notice that the L does not have a $sign after it. That's because the L is considered numerical. And because it's numerical and can be used in a math equation as a number variable, we would not put the $sign on there. Now let's talk about putting strings together. So let's clear some of this out. Okay. So given two strings, this program will add them together. And when I say add them together, I don't mean add like in a math problem. I mean they will be put together sort of like words like when you take rain and bow and you put them together and make a new word and it's rainbow. It's sort of like that. So print, pick a word, input, W1 $, 60, print, pick another word, input, getting ahead of myself, 80, print, W1, oops, $, plus W2, $. You should be able to predict what the output will be. So let's run that. So, for example, rain, bow, rainbow. What if I were to reverse them and put 2 first and 1 second? Predict, rain, bow, bow, rain. Notice there was no space. If I want to print a space, I have to put the literal space in. Sorry about that. Rain, bow, rainbow. Or bow rain because I had done it backwards. We could use this to ask for people's names, right? And print their names. John, Wayne, John Wayne. So that is basically the lesson for 1-5. I hope this video will help you visualize that better. If you have questions, please let your instructor know. Thank you.